Assalamu alaikum. Today we are going to determine the capacitance for a parallel plate capacitor. In this problem, we have this capacitor consistent of two parallel conducting plates. Let's say, before determining them, let's determine few constants regarding to the geometry of this capacitor. Okay, I will represent the area of this plate by A, and it's also the area of this plate is A. Okay, both of them have the same area, and let's determine the separation between these two conductors by D, and let's assume that the relative permittivity of the dielectric between these two plates by E sub r. It's the relative permittivity of the dielectric between these two plates. And regarding to the Cartesian coordinate system, y is upward and x is rightward, and the axial coordinate is z. Okay, to determine the capacitance, we are going to use this equation. C is equal to Q over V, where C is the capacitance, what we want. Q is the charge on these two conductors, and V is the potential due to these parallel conducting plates. Okay, how can you find the electric potential? V is equal to the line integral, is equal to the negative line integral between these two plates. Okay, and as we all know, the capacitor, regarding to the capacitor, one of these plates is negative and the other is positive. I'm going to make the one on the top positive and the one in the bottom negative. Okay, to find the electric potential, it's so obvious that we must determine the electric field. Okay, so let's determine the electric field by using Gauss's law. Gauss's law is the surface integral of the electric field around some closed surface. In this case, the closed surface is equal. The area of the closed surface is A. Okay, is equal to the charge enclosed in the surface that we are integrating around, divided by the permittivity of the dielectric between these two plates. Okay, it's epsilon is equal to the product between the relative permittivity and the absolute permittivity. Okay. In this case, the electric field due to this sheet on the top is upward at the area above this plate, and it's downward at the area down this plate. Okay, but in our problem, we want to concentrate in the area between these two plates, so the electric field in this case is downward. So it's so easy to say that the electric field, that the vector notation accompanied with the magnitude of the electric field is negative y unit vector. Okay, so the electric field, where this E without this bar above is the magnitude of the electric field. Okay, now the dot product between the electric vector field and the vector surface is equal to, regarding to this integration, is equal to A times E, is equal to E times A, where E is the magnitude of the electric field and A is the area of the plate. And by dividing both sides by A and by plugging the right hand side of this equation to this equation, we will end up with this is the electric field at the area between these two plates, and it's originated at this plate and it's sucked by this plate at the bottom. Now let's find the electric potential using this equation. Now the bounds of this line integral, let's say 0, which is the vertical location of the plate at the bottom. Okay, and D, which is the vertical location of the plate at the top. So it's between 0 and D. Okay, and regarding to this arbitrary path, DL is equal to the unit vector A sub x times x plus the unit vector y times dy plus the unit vector AZ plus dz. And by making the dot product between this arbitrary differential length and E, all components will vanish except for this component accompanied with the unit vector Y. So we will have in this. Now I'm going to plug the right hand side of this equation. Now by taking the integral, this integration is equal to, and by substituting d and d 0 for y, we will have, and this is the potential difference between these two plates. Now we can easily find the capacitance by substituting the right hand side of this equation for V in this equation, and we will have, okay, and now this is the capacitance. This is the capacitance for parallel plate capacitor is equal to the area of the plate times the permittivity of the dielectric between these two plates divided by the separation between these two plates. And you can notice that the capacitance is totally dependent of the geometry of the capacitors and the permittivity of the dielectric between these two plates. And that's the end for today. See you.